Good morning, guys. I thought I'd add this lesson on to to the last lesson in the series of function. I wouldn't say it's an advanced curve sketching tutorial, but it's more looking at how to sketch these graphs more quickly. I'm just going to go through very briefly the different graphs that we want to be able to draw, and then go through them through the ones we want to look at. So, looking at your y equals mx plus b, so your straight line equations, your f of x is equal to x squareds, your f of x is equal to x cubes, f of x is equal to 1 over x, our I guess x squared plus y squared equals r squareds, our f of x is equal to a to the power of x, so our exponentials, and also our y equals the square root of, let's say, 16 minus x squared, which is our semicircle. So just again, to briefly go through those, that's our straight line graph. Then we've got our parabola, we've got our cubic, our hyperbola, our circle, our exponential, and then also we've got our semicircle. Now obviously there are some other graphs that are, could be a lot stranger. There could be a combination of different graphs. They could have, for x is less than 4 and x is greater than 6, draw this particular graph. But this is looking at these particular types of graphs, which is a little bit quicker way of doing it. For the most part, when you're sketching any graph, there needs to be two things happen. You need to label your y-intercept and label your x-intercept, or septs. So those are probably the two most important things that you want to be doing with any sort of curve sketching. We do that for the y-intercept, thinking about that's our y-axis. Our y-intercept, wherever it hits here, is always at the point of x equals 0, and our x-intercepts are at the point where y is equal to 0. So through substituting those two values into any of these two the straight lines or these curves, they can get your answers pretty quick. So your straight line, let's have a look at your straight line to start off with. So your straight line, which is in the form of y equals mx plus b, very straightforward. We might get y equals, let's say, x plus 3, or x plus 1 then. Okay, so if you have your x and y axis, should be a very straightforward one, where we're simply saying, well, when x equals 0, because that's going to be my y-intercept, y equals 1, but also you can see that's going to be the y-intercept there, because that's y-intercept there. When x equals 0, so when y equals 0, 0 equals x plus 1, x equals negative 1, so that's negative 1, straight line. Okay, so you can see very quickly, without having to do anything else, no table of values, my straight line is very quick. So again, simply putting in x equals 0 and y equals 0, both times get you your two points, your x and y intercepts, you can draw a straight line. Your next one, which is the y equals x squared, or function of x equals x squared, so your parabola. This is obviously, you need to understand, in order to draw this quickly, you need to know what a parabola is going to look like. Otherwise, you'd have to fall back upon the table of values. For my liking, y equals x squared is a nice easy one. We should know that straight away. Okay, it goes to that point. But if you get a more complicated one, like x squared plus 2, once again, it's pretty straightforward because we know it's plus 2, so we know it goes to the y-intercept at plus 2. So this whole thing is just going to shift up. Okay, although it should go through that point there. If you get a more challenging one, I guess like this, you might get y is equal to x squared plus 3x plus 4. Then we still know it's going to go through plus 4 in terms of our y-intercept. It won't be at 0, 0 though. So what we can do, so when x equals 0, y equals 4. When y equals 0, then x squared plus 3x plus 4 equals 0. And it becomes a quadratic equation which we can solve. Actually, can we just change that slightly? I'm just going to put that as minus 4. So that actually works out better. So makes it 4 minus 1. So x plus 4, x minus 1 equals 0. and then we get x is equal to -4, x is equal to +1. So 1, 1, 2, 3, 4. Get our our two x-intercepts, and then we can sort of grab it. Now, obviously for parabola, if you're going to be more accurate, you'd also look at your axis of symmetry. Obviously, if it goes through -4 on 1, okay, you look at for halfway through that point, which is going to be 2.5 thereabouts, I'd say, or around there somewhere. Okay, and you chuck it in there. You can use the formula x equals -b/2a for the axis of symmetry. However, if you just recognize it's going to be halfway between those 2 points, so 1 plus 4 is 5, so half 5 is 2.5 units across. So it's 1 across, 2 across, 2.5, well, -1.5, should I say. Okay. But anyway, look, that's a very rough guide, again, of a parabola. You've done plenty of those. But I guess the more challenging ones are going to be, I guess, your cubics. Certainly your cubics are going to be more challenging here. So your cubics there, particularly your hyperbolas, etc. And I guess it's always important to know whereabouts your first one sort of looks like, that basic one. So if we look at y equals x cubed, well, hopefully you know automatically that that's the way it's going to look like this. Okay. You can get away with doing that straight away. If you're not sure, if you get something like this, y equals x cubed plus 1, again, just find your x and y intercept. I mean, your y intercept is going to be a bit more, your x intercept is going to be more challenging there, but your y intercept certainly, at x equals 0, y equals 1, so there you go, 1, and this replicate is going to go up like that. If you're finding y is equal to 0, then we've got x cubed equals -1. Well, in that case, it's not too bad, because if x cubed equals -1, then x equals -1, all right, which is a cubed root, which is going to be there. So you can put your -1 there, etc., and you can put your +1 there. So again, it's just putting on your x and y intercepts when you possibly can. There will be more challenging ones, but I guess for the most part, at the moment, they'll be pretty simple like this. After that, I said hyperbolas, so your y is equal to 1 over x. Once again, it's important to know, a hyperbola looks sort of like this. How do I know it looks like this? Well, number one, I've been teaching this for a while, but also two, we know we can't divide it by 0, okay? Because in this case, x equals 0, it can't be 0. So that's going to be what we call our asymptote, okay? So we just put them either side. If you get something like, I guess, y is equal to 1 over x minus 2, for example, well, we know in this case, x cannot equal 2, so I'm going to count 1 and 2, and that would be where my asymptote would lie, for example, like that, and then we can draw our asymptotes as per se. All right, so knowing what x can't be, draw your asymptote line in, and you can usually work from there. For those more challenging ones, I guess also that you could do a table of values to help you, but if this is a quick sketch, then that should really tell you how to do it. Then obviously we get our exponential. Pretty straightforward for our exponential, so y equals 2 to the power of x. Our exponential, we know, once again, is going to look like this. For the most part, it will cross through 1, because when x equals 0 to the power of 0, anything equals 1. But I guess if you chuck a plus 1 onto it, then obviously by substituting x equals 0 into it for our y-intercept, it'll be 1 plus 1 is 2. It'll be the same line, but it's going to go, through that point there. Knowing that it can't equal 0 either is going to help. So just labeling in this case, putting your 2 there, and then drawing a line in, showing that it's not going to touch the y-axis, so that the x-axis, sorry, would probably sort it out. And I guess the last two I want to look at, which should be pretty straightforward, x squared plus y squared equals r squared. We've done circles before, where in this case the center is at 0, 0. We should know that. Whatever this is, so if we do x squared plus y squared equals 16, then obviously that's my radius is 4. So straight away I can say 4, -4, +4, -4, okay, and then I can simply draw my circle in, pretty much. Depending on where it's at, if I have, if it's x minus 4 squared plus y minus 2 squared equals, let's say 100, okay, then the center is going to be at 4, +2. So 1, 2, 3, 4, 1, 2. That's where your center would be. And because the radius in this case is 10, I'm going to go 10 that way, 10 that way, 10 that way, and 10 that way. And then I'm simply going to draw it. Okay, so your circles are pretty easy. The more challenging aspect, I guess, is when you get the semicircles. So the square root of, let's say, we get 25 minus x squared. That is a semicircle. Once again, you just need to know that's a semicircle, and you need to understand that that 25, that's your r squared, your radius squared. Also, it's a positive here. It's not a negative. When we draw it, okay, I'm looking at here, it's at center 0, 0. So I'm going to go up to where, in this case, it would be 5, -5, and +5. And I'm going to draw my semicircle in. If it was negative here instead, then it would be the bottom part. Okay, and that would be -5 there. So that part there is always a radius. Because it's at y and x is at 0, 0. You can work from there, and you know, when we're dealing with semicircles at the moment, we won't deal when the center is at a different area. Okay, it's always going to be at 0, 0 for our particular questions. Okay, so very brief rundown on a quick way to sketch your graphs. But for the most part, if you're unsure what it's going to look like and you've never seen that type of graph, you've got absolutely no Scooby idea of what's going to happen, then I suggest to go from -3 to +3, and then just plot your points for your function. So whatever your function might be, and then you can plot your points around there. Okay, but we should be getting used to drawing or sketching graphs a lot quicker now. Okay, any problems? Let me know. Otherwise, just practice makes perfect. Have a good day.